Pillar 2, RNC principles, understand token. First, we have blood volume distribution. Most of the blood is in the venous system. You can see the breakdown in this chart. Yeah. Ohm's law. So we all know that Ohm's law is V equals IR. Voltage equals current times resistance. We can relate that to the heart. And so in that case, voltage compares to pressure, current compares to flow rate, and resistance compares to resistance. But in this case, it's resistance to flow versus like resistance to current. The units for resistance are called peripheral resistance units, PRU. Total peripheral resistance refers to the amount of force affecting resistance to blood flow throughout the circulatory system. Pulmonary vascular resistance is the resistance against blood flow from the pulmonary artery to the left atrium. Poiseuille's law is in the equation to the right. It is the equation for flow rate, which is Q. As you can see from the equation, resistance to flow is highly dependent on the radius. You can see when it's rearranged in terms of resistance that radius is in the denominator and it's raised to the 4th power. And from that you can also see that that's non-linear. So compliance and elastance is basically how like stretchy something is. So compliance is the change in volume over the change in pressure, and then elastance is the reciprocal of that. So it would be the change in pressure over the change in volume. The units of compliance are there, and then the elastance would just be the reciprocal of that. An example of compliance is a balloon that is easy to inflate is highly compliant because an increase in the volume of the balloon causes a small change in the internal pressure. All right, pressure and volume. That red line is for the arterial system. As you can see, a small change in volume will cause a large change in pressure in the atrial system, or the arterial system, excuse me. And in the venous system, a small change in volume will cause a small change in pressure. It makes sense that most of the blood would be stored in the venous system because of this. The elastance of the arterial system is much larger than the venous system, which means that the compliance of the arterial system is lower than the venous system.